All right, so we're going to go ahead and apply that approach sort of to a generic problem. Which is going to be y double prime plus p of x times y prime plus q of x times y equal to 0. We're going to say that we're given y1 of x is a solution, which means that when you plug it in, y1 double prime plus p y1 prime plus q y1, you'll get 0. That's what it means to be a solution. And we're just going to start following those steps I told you we would use. So we're going to assume that y2 is equal to some function u that we don't know right now times y1. And then we're going to go ahead and take derivatives because eventually we'll want to plug it into the differential equation. So I'm going to need the derivatives of this potential solution. So y2 prime, I'm just going to use the product rule real quick. It's u prime times y1 plus u times y1 prime. And y2 double prime is just two product rules. So I'll have u double prime y1 plus u prime y1 prime from, there's that first one. And then from the second, I'll have u prime y1 prime plus u y1 double prime. We'll do a little dashed line right there. So all I've done is apply the product rule twice. And that's going to simplify u double prime y1 plus 2 of those middle terms plus u y1 double prime. And I'm just going to plug it into the differential equation and see what happens. So if 0 is equal to y2 double prime plus p y2 prime plus q y2 is something that I want to be true, I want this to be a solution, then that's going to mean, just by plugging the derivatives I took just now, u double prime y1 plus 2u prime y1 prime plus u y1 double prime plus p times u prime y1 plus u y1 prime plus q times u y1 should be equal to 0. And I just have to rearrange this to sort of try and cancel out the y1 terms. So what's going to help me here is going to be to remember that this is equal to 0 and try to pull out terms that look like that. So what I've got is 0 is equal to u double prime y1 plus 2u prime y1 prime plus u y1 double prime. I'm just rewriting it here because it's hard for me to underline stuff and flip between the pages. And I want to make sure that I'm showing you where all these terms come from. So my idea is that the y1 double prime plus p times y1 prime plus q times y1, that thing should cancel out. And I noticed that all of those terms are attached to u. So what's going to help me here is to try and group my terms that way to start out. So I'll say u double prime y1 plus 2u prime y1 prime. I don't really have much use for that yet. And neither do I have use for pu prime y1 right there. Since I've changed the order on that, I'll just underline it real quick. But I do want to see these things together. u y1 double prime plus pu y1 prime plus q u y1. And those terms I took from right here all together. And I can factor out the common u right there. So that I just have y1 double prime plus py1 prime plus qy1. And that term is equal to 0 because y1 is a solution of the differential equation, and that's what it means to be a solution to the differential equation. So now I have u double prime y1 plus 2u prime y1 prime plus pu prime y1. And I'm still not quite sure how I could solve this. But if I group together my terms like this, it's at least a little bit simpler. I've got my u double prime right there attached to some stuff and my u prime right there attached to some stuff. And the thing that's going to make substitution work is going to be, the thing that makes reduction of order work is going to be this substitution. So I'm sort of looking at a second order differential equation, but if I just change what I call my variables, I'm actually looking at a first order differential equation. And we know how to solve those. So now my problem is to try and solve 0 equal to sort of w prime y1 plus w times 2y1 prime plus py1. Or it might be easier to think about it sort of y1 dw dx plus 2y1 prime plus py1 times w. And y1 is a solution of the differential equation. It's a function of x. It's given to us. And this right here is just a first order differential equation that we can solve any way we want to. And the way I'm going to pick is going to be separation, because I like separation. So let's see, I've got negative 2y1 prime plus py1 times w is equal to y1 dw dx. So negative 2y1 prime plus py1 over y1 dx is equal to dw over w. I'm going to move that y1 inside this fraction, sort of split it in two. Negative 2y1 prime plus p over y1. So my problem here is to integrate both sides. This is got to make sure I'm careful about that negative sign. Don't want to forget that I have to distribute it around. If I'm going to solve this separable equation, I need to go ahead and integrate both sides. So I've got natural log of w on the right-hand side, and it's just this integral right here that's going to give me a little bit of trouble. So I can go ahead and try to break it up into two pieces. Oops. You can even pull the 2 out. Integral y1 prime over y1 dx minus integral p dx. And I'm going to have to note that this integral might not be super obvious, but kind of think about it in reverse. If you are trying to take the derivative of the natural log of a function, then you would get like 1 over the function times f prime of x by the chain rule. So we're going to go ahead and continue on. And we'll get sort of the natural log of w is equal to minus 2 natural log of y1 from that first part, minus the integral of p dx. Since we don't know what p is right now, we can't really solve that, plus c. And we're right at 10 minutes, so there's a little bit more to this, but I'm going to stop here so that you can take a quick break, and then we'll wrap up the rest of the algebra and undoing the substitution in the next video.